All right, we'll go ahead and finish up section 2.2 in this video. So the last thing to talk about is piecewise functions, or functions that have several parts to them. So let's take a look at some examples here. In this first example, suppose that we want to graph the function f of x equals x squared if x is less than or equal to 0, and x minus 2 if x is bigger than 0. Okay, now with a piecewise function, you got several different pieces. So here I got two pieces, and these if conditions, like I'll worry about them later. Okay, but so let's go ahead and graph this curve first. Okay, the first part is where I have y equals x squared. Okay, y equals x squared is the square function. We looked at that. That was in the last section. Is y equals x squared, and that's a parabola centered at the origin facing upward. So I would begin by graphing that parabola. Okay. Now I don't want the whole parabola though. I only want the part for where x is less than or equal to 0. So here is 0. Anything that's less than 0 we're going to keep. Anything that's bigger than 0 we're going to erase if we had drawn the whole parabola. Okay, so I would erase everywhere that's to the right of 0. And we're including 0. So you want to make sure that 0, 0 is on the graph. Okay, piece 1 would now be done. And now I'm going to move on to piece 2. So I got y equals x minus 2. Y equals x is the identity function here, and we'll learn about lines, coming up. But here's y equals x. Y equals negative x would be a line flowing through quadrants 2 and 4. Okay, so I got a line, facing this direction, and it's x minus 2 though. Okay, if x is 0. 0 minus 2 is negative 2. So there's 0, negative 2. Now I want to make sure that that point is not on the graph, because x is strictly bigger than 0. To make sure that a point is not on the graph, we use an open circle. Okay? And then I'm going up 1 to the right one, 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 and I gather up a whole bunch of points on this line. Okay? So now when I graph a piecewise function, I want to make sure that the end result is a function. Okay, it's going to pass the vertical line test. So now if I swing a vertical line across this graph, it's going to pass that test, right? So anywhere that I would draw a vertical line is going to intersect the curve in only one point everywhere. Even at 0 here, like if I draw a vertical line at 0, 0, 0 is on the graph. 0, negative 2 is not on the graph. Okay? Let's go ahead and state the domain and the range of the function. The domain would be all real numbers. Now, I can easily get the domain without a picture, because we're describing f of x for when x is less than or equal to 0, and then for when x is bigger than 0. Well, that's all x's. Okay, so the domain would be all real numbers, or all x values. I can also get that from the picture. Okay, so if I look at the graph and I scan the x-axis, look above and below each spot, if I'm on the curve, I'm in the domain. If I'm not in the curve, I'm not in the domain. So it's not going to matter where I'm at, because these arrows are going upward and outward in the two directions, going to cover the entire x-axis. The range of the function is asking for the y values. Okay, so, well, if I scan the y-axis, and to get the range, it's helpful to have a graph there. But if I scan the y-axis and look to the left or the right of each value, if I'm on the curve, I'm in the range. If I'm not in the curve, I'm not in the range. So here, it looks like anywhere that is bigger than negative 2, if I look to the left or the right, I'm going to be on the graph. Anywhere that's less than negative 2, I'm down here, and I don't have any graph down here. Okay, Now I want to make sure that x is strictly bigger than -2, not greater than or equal to -2, because 0, -2, again, that point is not on the graph. You can use set notation or interval notation is fine. So, -2 to infinity, just make sure that there's parentheses at both ends there. Okay. Now, like any other function, there's input values and output values. So, if x is 3, now one of the things about piecewise functions is that you're gonna have to figure out which piece that the number is going to be plugged into. Okay, so if I'm plugging in 3, I need to use piece 2 because 3 is bigger than 0. 3 is not less than or equal to 0. So I'm going to do nothing at all with piece 1. Okay, 3 minus 2 is 1. And so 3, 1 is on the graph. Yeah, that point is there. That's the point that I plotted earlier when I drew this picture. What if x is -2? Okay, well then I'm going to use piece 1 because -2 is less than or equal to 0. -2 is not bigger than 0. So we're going to do nothing at all with piece 2. -2 squared is 4. And so -2, 4, that point would be on the graph. And yeah, that's another point that I plotted. Okay, so again, you're only plugging in the number into one piece depending on these if conditions there. Okay. Let's go ahead and try another example. So what if I had the function f of x equals x plus 3 if x is between -2 and 1, including -2. We're going to have 3 if x is equal to 1, and then -x plus 2 if x is bigger than 1. Okay, let's go ahead and graph this curve. And we'll state the domain and the range, and then we'll plug in a couple of numbers here. Okay, so the first thing, I got y equals x plus 3. Okay, again, y equals x. That's the identity function. If I'm adding 3, then, well, why don't I go ahead and plug in this left value here? -2. So -2 plus 3 is 1. So -2, 1, that's on the graph. And if I plug in 1, 1 plus 3 is 4. Okay, so there's 1, 4. Now, I have these 2 points on the graph, and I draw a line between those 2 points. Okay? Anything less than -2, I don't want that, so I would erase that part, if I had drawn this entire line. Anything that's bigger than 1, I don't want that part either, so I would erase that part if I had drawn the entire line. X is including -2, so I want to make sure that -2, 1 is a closed circle. Okay, we're not including 1, so 1, 4 has to have an open circle on it. Piece 1 is now totally done. Okay, so how about piece 2? In piece 2, I got y equals 3. Okay, y equals a number means that I have a horizontal line, and here would be at 3. Okay, so I begin by drawing the horizontal line at 3. Now I don't want that whole horizontal line. I only want it to show for when x is 1. Okay, so anything that's bigger than 1, I would erase. Anything that's less than 1, I would also erase. And that's just going to leave me with a single point, 1, 3, on the graph. Okay, so piece 2 would be done. In piece 3, I have -x plus 2. Okay, so the line is going to be slanted in the negative direction. Okay, let's see. So I'm starting this at 1. If I plug in 1, here's -1 plus 2 is 1. Okay, so 1, 1 is there. Okay, and then I would draw the line, heading downward and outward into quadrant 4. Okay, so I'm going down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And we're not including 1. Okay, so the point 1, 1, that's not on the graph. And I'm all done with this curve. So it's going to pass the vertical line test. If I draw a vertical line anywhere on this picture, it will pass the test. Okay, it's only going to intersect the curve in 1 point everywhere. Okay, even at 1, because if I draw a vertical line at 1, the point 1, 4 is not on the graph. Also, the point 1, 1 is not on the graph. Right? They got open circles there. 1, 3 is on the graph. Okay, so that would intersect that vertical line at 1, 3. All right, and let's get the domain and the range. So the domain is all real numbers that are greater than or equal to -2. Well, I can easily get that without the picture. Okay, so in piece 1, x is defined for when we have x being greater than or equal to -2 and up to 1. We're including 1 in piece 2, and then anything bigger than 1 in piece 3. Well, that's, when you put all that together, that's all x's that are bigger than -2. Okay, so and again, you can use set notation or interval notation is fine. So anything greater than or equal to -2 means that I have a bracket by -2. -2 to infinity would be that interval. Okay, the range of the function is asking for the y values. So if I look at the graph here and I scan the y-axis and I look to the left or the right, if I'm on the curve, I'm in the range. If I'm not on the curve, I'm not in the range. So it looks like anywhere that is less than 4, when I look to the left or the right, I'm beyond the graph. Anywhere that's bigger than 4, like if I let if I'm at 10 up here, and I look to the left and the right, I don't have any graph up here. Okay, so 1, 4, that point is not on the graph, so I want y to be strictly less than 4. Okay, or here's the set using interval notation, -infinity to 4. Just make sure that you're not including 4, so you got a parentheses by 4. And then, so, like any other function, there's input values and output values. So like if I plug in 4, I need to figure out what piece I'm plugging 4 into, depending on x. Okay, well, 4 is bigger than 1, right? 4 is not equal to 1, and 4 is not between -2 and 1. So I need to plug 4 specifically into piece 3. -4 plus 2 is -2. So the point 4, -2, that point should be on the graph, and yeah, here's that point. Okay, having the graph there is good because I can verify that the point is on the graph, right? I don't want to point like way over here or something like that. It's not on the graph anywhere. If x is -1, okay, I'm gonna be using piece 1, right? Because -1 is between -2 and 1. -1 plus 3 is 2. So the point -1, 2, yeah, that'd be right there. That's on the graph. Okay. Let's try another one here. So one of the basic functions that we looked at was the absolute value function. The absolute value function is always a V-shaped graph, centered at the origin facing upward. Okay. And now you can define the absolute value function as a piecewise definition. So it'd be x if x is greater than or equal to 0, and -x if x is less than 0. And the only reason why we're doing that is because this is a way to say to somebody that, hey, anything coming out of the absolute value bars is never going to be a negative. So like if I plug in -6, and I want to know the absolute value of -6. Well, -6 is less than 0, right? So I should be using piece 2. And in piece 2, I'm told to take the opposite of x. Well, the opposite of -6 would be +6. Okay, so the absolute value of -6 is positive 6. And now in piece 2, we're saying, okay, do that in general whenever x is a negative. Just take the opposite of that number. That way you get a positive. Otherwise, if the number is positive in the first place, you're just going to keep that same value. Okay? So then, let's see, I got these two pieces here. Y equals x is right here, right? Now, I don't want that whole line. I only want the part for when x is greater than or equal to 0. So here's 0. Anything bigger than 0, I'm going to keep. Anything less than 0 would be down here. I'd erase that part of the line there in quadrant 3. Okay, piece 1 would now be done. In piece 2, we have y equals negative x. So that'd be a line in quadrants 2 and 4. We don't want that entire line. We only want the part where x is less than 0. Okay, so here's where x is less than 0, and here's where x is bigger than 0. I would erase everywhere that's bigger than 0 or everywhere that's in quadrant 4. Okay, and so then I'm done with that curve, right? So one way to describe the absolute value function is as a v, but another way is you can describe it as two lines, and you're sticking them together to form a v. Okay, and 0, 0 is on the graph. Okay, so sometimes when you have a piecewise function, you got one piece going into another piece, and it joins. You know, like we had 3 pieces here. None of these 3 pieces joined with another piece. Okay, but yeah, so sometimes it will happen where, you know, one of the pieces joins with another piece. Okay. Let's try this example next. So write a formula for the graph. So what if I had this graph and I want us to write a formula for it? Okay, what they mean by that is which one of these basic functions represents these curves here? So this curve here, it looks like the square root function. Okay, and so I got y equals the square root of x, and that would be for when x is greater than or equal to 0. Okay, that'd be piece 2 that I've got written there. And then this other piece that's in quadrant 3 looks like it's part of the reciprocal function. Okay, so I got y equals 1 over x, and I'm only using that piece if x is a negative. Right? X positive means that you'd be in quadrant 1. I don't have that piece showing in quadrant 1 there. So I need x to be a negative. Okay, and so this would be the answer. This is the function representing the graph. Okay, there's a couple problems like this in the book where they give you a picture and they want you to write a formula for the picture. Okay, so the idea with those is that you want to identify which one of these basic functions are you talking about, and then you'll write the basic function down and then the conditions on x. There. Okay. Sorry, that's it for this section. The homework in 1-2 is on page 33. So have a go at those problems when you get a chance.